So let's continue on. I think this is about where we left, and hopefully you can see this. Folks back in not here at the college, can you tell me? Can you see the screen here? Can you see the layer 7 presentation?
Yes, sir.
Yes, sir.
All right, so that's where we are. That's good. All right, let's go. So the 7 layers, the application layer is referred to as layer 7. That's where our applications come. And there's actually sort of 3 layers. If you look at the TCP model of the protocols, it only has 4 layers, and it basically collapses the top 3 layers because that's all you need to get to your transport layer. But yeah, the application layer protocols, as it said, are used by programs. So you'll have an application where something is being used on one client at a remote location. It's using this protocol. Maybe it's email. That's the example we've been using. So it's going to be using your email protocols like this SMTP. And then on another device remote from that, long way away, the end recipient of whatever's happening there is going to be using a similar or related protocol. Now they are different in email, aren't they? Because this one is going to be using the SMTP. This one's going to be using POP3 or IMP. So, you know, we want to, if we're using a browser, on the other hand, then it's going to be HTTP on either. So we can be communicating using that. So the application is going to be providing those. The application layer is going to be providing that those applications on either end, and the protocols are there to support them with that. And we've mentioned some of those. So, for example, SNTP with your email. The payload. Okay, so the payload. When we talk about that, we actually break the messages that we pass along our networks. We break them into chunks. Okay, so you chunk them into sort of sizes, and this is done at sort of transport layer level. We break them into, depending on which protocol we're using, they can be variable size chunks, or they can be all sort of regulated size chunks. And then those chunks have some information on them for the protocol, TCP or UDP, and then we're going to call that a segment or a PDU. So that's going to be your payload with the TCP or UDP protocol addressing on them. That's going to be a segment. And then the segment is going to be passed down. Now, so layer 6, we still haven't got to that yet. Layer 6 is just your presentation, you know, how are we going to show this from this screen to that screen. And as it says there, if you're going to do any reformatting, compressing, this is your layer 6 is before we get, sorry, I skipped ahead there, didn't I? But layer 6 is before we get to the transport layer going down, because transport layer is layer 4. So layer 6 and layer 5, we're taking that that email and presenting it in a way we're actually not, we're not looking at any addressing information there yet. Layer 5, the session where the applications are synced, right? So again, we're still, if you're using the TCP model, we would just, these would all be collapsed together. That's all done together, and we don't even divide these out. And so that's why it says it's kind of hard to distinguish between them. They are intertwined, and actually they can be sort of in at least one model, they're all put together. All right, so the transport layer, that's where things start getting interesting. Transport layer, that's layer 4. So we've taken our data payload and we've presented it and we've synced it, and now we're going to put some addressing there with a protocol of TCP or UDP. And so your TCP is going to hold up a connection between the hosts. UDP is not going to sort of guarantee that so much. So your TCP uses a lot more, it's going to be more certain, because what happens with TCP is if you have any errors in the data that's sent over, then you're going to resend. So we get the exact data through that we sent. And so it can take a little longer, and there's a little bit more sort of data used for that. Whereas your UDP, that's going to, it's it's not so where it doesn't hold a session. So your transmission control one holds a session up. Your UDP will just let the packets get through if they can. It's sort of a best effort thing. And so your UDP is going to be faster relative to the amount of data that you're sending, but it won't be as secure. So I hope that you can see where we would use these different protocols. They do have different applications. If you're doing a banking application, you'd want to be using TCP because you want to make sure that every bit of that data gets through, right? One number changed in a credit card number, that's going to cause a problem. So you need to get the exact amount, the exact data through. If you're doing a video call, like our Zoom, they wouldn't be using TCP because, we have glitches and stuff like that. The problem is if we went back and sort of fixed every dropped bit of data, we would start getting a big lag. Things would slow down for us so bad. And so we with the UDP, we just do a best effort. Oh yeah, that bit of data that got lost. That's okay, So I mean, so we can't see that person's face for a couple of seconds, but now we can. And so that's okay. It's not sort of data that's sort of essential. So we're introducing here this concept of encapsulation, and that sort of starts at the TCP layer where you get this chunk of data, which is turned into either a PDU or a segment, depending on which protocol. And so when you design your application, you will decide there the protocols that you're going to be using. And as I said, you got that choice of UDP or TCP. Now, with these at the transport layer, the message can be broken down. Okay, can be broken down to be a size that will fit. Data. So I use the word PDU. It also calls it a datagram there. All right. So the network layer, layer 3. This I think is perhaps the most interesting one for us as students because this is a layer in the OSI model where we do a lot of work. Because it's where we're doing the logical addressing, and that's IP addresses. And so if you're a network administrator, you may have to design the network, and part of that would be where you're assigning IP addresses using some network operating system way of doing it. So there's a couple ways of doing it. You can do it sort of automatic assigning, or you can, as you're designing and laying out the network, there will be certain parts where you will assign sort of a IP address to different nodes. So yeah, we have IP addresses. Your IP addresses, you'll remember those are things like 192.256. They got the 4 sets of numbers. That's your IP address. And thing is, we have IP version 4, IP version 6. I haven't seen people using IP version 6 so much, though it is available. But the thing is, we don't have an infinite number of IP addresses. So there is work, particularly if you're working in an IP4 environment, it's definitely not an infinite number of addresses. And so we have to do a lot of juggling around. There's a little bit of work for network administrators in sort of optimizing the networks using IP. So each node in the network has to have an IP address. And the IP address is used to uniquely identify that node in the network. IP addresses are handled by routers. So routers is going to use the IP address to direct the packet to go to the right place. So we call that a packet. As it says, we've got some special protocols that are used by the routers. ICMP and ARP are used to make sure that those packets get through to the place that they're supposed to go through. The network protocol can divide larger packets into smaller packets, called fragmentation. Now, layer 2, what you're doing with layer 2 is you're taking that packet. So we had a segment or a datagram, and then we had a packet, layer 3. Now at layer 2, we have a frame. So we're taking that packet and we're adding some physical addressing to it. Physical addressing is going to relate to the address on the NIC. And yeah, so the devices that are working at layer 2, as it says there, Ethernet and Wi-Fi. Well, that's our layer 1 actually, but Layer 2 devices are going to be our switches, which are going to sort of work with those MAC addresses. And here's the MAC address, which is required for our layer 2. And so it's a hardware address. It's physically kind of burned into the device on the card somewhere. So that could be an add-on card, or it could be in the device itself. But each device has to have its unique MAC address. Okay. The physical layer is just talking about how we actually transmit from one sort of point on the network to another. And so typically it's going to be a wire like Ethernet, or it could be using radio waves or fiber optic with lights. Yes. So the physical layer is very interesting for telecommunications people. Yeah. And you get involved with that too, right? With laying cables and connecting them to the devices, etc. So our segments are datagrams, or PDUs, as I called them, the payload data, the packet, the frame. You notice we're using a different name as we go to different points in the OSI model. And down at the bottom layer, we're looking at the actual bits at a time, so we're taking our frames and putting them onto the wire or the Wi-Fi. I hope that you got from what I was saying that we've got a diagram that shows it. So yeah, there it is. So yeah, so the payload is there. And do you see that every time we go to another layer down, we're adding something to the chunk of data, which we've called the payload. So the payload gets a header for the segment or the datagram. And when it becomes a packet, it gets another header. So you see now it's got 2 headers. And when it becomes a frame, it gets another header, but it also gets a trailer. And then so the frame is the thing that's actually put onto the wire. And so the device is going to receive that, like a switch. It's going to have to analyze that header. And then it'll usually strip the header and the trailer off, and then the packet will be revealed inside, and that can be dealt with by a router. And so that's what's happening there. Is you see that it stripped off. So the frame arrives at the router, and it came with a header and a trailer, and those are stripped off. And so now we've got the router is looking at the packet, and the router is going to analyze that packet, where it should go, and then it's going to add a new header to it and trailer, which is going to turn that into a frame, which will then be sent out onto the network again. And then when it arrives at its destination device, in this case the server, then it will decapsulate or de-encapsulate. So the frame will have its header and trailer removed, and then the packet will be revealed. And then because this is a terminating device, it'll say, oh yeah, that's meant for me. So I'll take off that header. Okay, there's that segment. Yeah, this is my segment, so I'm going to remove that and look at the payload. All right, so that is all the networking for this course for today. So the rest of this lecture, which is another, looks like 12, 15 slides, is about all this safety procedures and policies. And I guess it's important, it's there, but I don't know if I'm going to go through it kind of fast because I think it's stuff that you've looked at before. So basically, you need to keep yourself safe. And we're very, very aware of that now because of COVID, right? But aside from that, there's other safety things that you have to consider in a networking environment, right? So you've got voltage to consider, your own safety, and the equipment itself. And so let's look at that just briefly. What can we do to keep ourselves safe? Well, one of the things that we have to be able to do is if there's a fire in the building, we need to know how to get out. We need to know what systems are in place. So like we got a fire extinguisher there. If you hear a fire alarm, there's a place that you should familiarize yourself with. When we leave the building, where do we go? We don't just go and mill around. We go to a assembly point, and you will see them around the college. There's one out there in that garden. There's one out in the car park. And so as you, if there's a fire alarm, you need to go there. Now, when I was working in Telecom Australia, I worked in Telecom Australia for a few years. My first few years in computing, actually. I was in a 13-story building, and they asked for volunteers in the building to be fire wardens, and I volunteered, because I was keen, young guy, and I actually became the chief fire warden for the building, a 13-story building. And so I got an idea what happens in a fire alarm. We'd have fire alarms kind of regularly, and they'd even send out the fire department. They'd send out the fire truck to the alarm, and we had to get everybody out of the building. And what we had in that building was everybody had to sign in. When you came to work, you had to sign in. And so when we had the fire alarm, all the sign-in sheets would come down to the fire ward, and then you'd see who signed in, and we'd have somebody going. We had a warden on each floor, and we'd check who was out in the waiting area, who came out of the building, right? So if you on your floor you had 100 people signed in, and then we go out there, where's those 100 people, right? And so maybe one of them's not there. Then what are we going to do as a fire warden? Well, we'd send the fire department up there to find them. So I mean, if you have a very strict fire policy like we had, it was like that. Couldn't sort of go milling around. We had to wait. The fire warden would come out and check to make sure that you're out of the building. And that was for their safety, right? Because maybe there's a fire and there's somebody in that building. We've got to go and get them. But if they're not in that building, we don't want to send the fire department guys up to risk their lives for somebody who's gone to get a Starbucks. You know what I mean? So it's quite important, right? So I don't know if that'll come like that here, but it might. That's certainly the way that we did our fire. But the other thing that you should be aware of is the fire extinguishers, etc. I don't know if you're interested in all these, my old stories of back in the day, back when people didn't have long beards like I got. But the other aspect of the fire that may be interesting to you, that when I worked in a telephone company, is we had one of the floors of the building was the communications. All of the communications computers were in that room, and so that room had a self-locking door, and it had freon gas, which was automatic. So when a fire alarm would come, then there would be a big alarm in that room. That room usually only had 1 or 2 people in it. Because how many people do you need to run a server room? They basically run by themselves. They're just there to take care of issues. So when that fire alarm went off, you got like 3 minutes to get out, and then the door locks, and then you're dead because it would put in the gas to suppress the fire, to protect the thing. So yeah, I mean, fire is a big deal, I guess is what I'm trying to say. So fail open and fail closed is a security system. So that the idea of that is, we have locking doors all over the building, all over the room. So when we design, and you might be in a situation where you have to design a safety system for fires. So what are you going to do, right? When there's a fire, are you going to lock the doors, or are you going to open the doors? We had that one in that server room where we locked the doors, which I think, when thinking back on it, that's kind of dodgy, right? I mean, somebody died in there. I think, you probably want to be able to open the doors, right? So what's the problem with open doors? Open doors are actually a fire hazard, because that open doors is how fire spreads from one room to another. So if you can close the doors, that's better. But, you don't want to close the door and lock people in. Sorry?
There are doors that make the fire.
Yeah, you can have very strong door, and they will lock. And yeah, you want to make sure you're on the right side of it. And so, I mean, that's very important. The doors can be used as you go out your rooms. If you're in an office, you want to close the doors, but you want to make sure there's nobody in there. And another thing is the fire escapes themselves, right? A lot of buildings, our building included, you might have a lot of room around the fire stairs, and so some people will try and take advantage of that room and start putting things in there, cupboards and stuff. Very bad. People running down the fire escape, and they can't get out because there's stuff in the fire escape. Anyways, there's this thing called Msds. I teach chemistry when I wasn't teaching computing. I have a few different degrees that I got, so accounting, chemistry, and computing. But in the chemistry department, there's a lot of very dangerous chemicals, and they may also, for some reason, I suppose, show up in in another environment. But in which case, every chemical that you have in a chemistry is going to have this this identification, which will then be referenced to an MSDS data sheet. And so you can go online and you can find out exactly what to do in case this chemical becomes free in the environment, right? Like if it's spilled on somebody's hands or somebody drinks it, you know, these horrible things. Now that should be on the chemical bottle themselves. So if you see any chemical, you should check the bottle to see if that's there. But if it's not there, there will be a data sheet. And by the name of the chemical, you can quickly go online and you can find out this information, which, you know, could save somebody's life, I suppose. All right, so occupational safety, and there's a lot of guidelines to do that. There it mentions PPE. We're all aware of PPE at the moment because this is PPE. But you know, other PPE is boots that don't allow liquids to get through, waterproof boots. So you guys are wearing just your shoes. I mean, I was teaching in the chemistry lab there for a while back, you know, 7 years ago. We wouldn't let you in. You know, you got to have something, or well, we probably might with shoes, but we wouldn't let you in with sandals. You know what I mean? Because you could just spill some chemicals on that, right? It's got to be PPE. And also, if you're working in chemistry, you'd have to have a jacket. You couldn't just go in with your shirt like this. You'd have to have something that's going to repel a bit of chemistry. Then you're going to have glasses and gloves. And so, and you might have a face shield. And some of those things we use for biological things like COVID, all right? So those guidelines are there. Other guidelines, so for example, just on that mundane thing, working in the chemistry lab, we wouldn't let students into the lab unless there was two instructors there, right? So, you know, that's another safety thing. So just sort of rules like that. Yeah. What else? Lifting heavy objects. Okay, yeah. Protect your back. I don't think I need to talk about that too much, do I? Yeah, you know that you can hurt your back if you don't lift in the right way. You can hurt your back by sitting wrong. You can hurt your back at home watching TV if your furniture isn't you know what I mean? If you lie in the wrong way. Static electricity. This is important for us. So what you should have is you should have some way of dissipating the static electricity before you start working on it. So you might have a device that you connect to it, which will ground the device. Another thing that you'll do is before you stick your hand in there is you'll ground your hand, right? You'll touch something which is grounded before you touch the device, because otherwise you could build up some static electricity on your, especially if, you know, we got rubber shoes or woolen socks or something like that. You know, we're insulated from the ground. So electricity is not flowing from us into the ground. And so we need to get that, you know, if we have something metal we can touch and just get rid of any what we call static electricity, which is built up on us. Because if we don't, when we come near to the computer device, it might just jump across. And when it does, that's many, many volts, which is enough to sort of damage computer componentry. So that's the static electricity. Can cause problems. So ground yourself before you do that. And there's different ways that you can do that. So see what this person is doing, how they're grounding themselves. They've got a device on their wrist, which is connected to grounding so that they don't, so there's no sparks coming across from their hands while they're sticking their hands in the computer. All right, so that's the bit on safety. So it looks like we got 5 slides on troubleshooting. Are you guys familiar with this concept of troubleshooting? So the troubleshooting, what I want to stick in your mind about troubleshooting is we use the OSI for troubleshooting. The OSI is a 7-layer model, right? So how do we use the OSI for troubleshooting? Well, we start at one end of the OSI. We either start at the layer 1, which is the hardware, or we start at the layer 7, which is the applications. So depending on our analysis, so first we have to look at the problem and come up with an initial analysis. What do we think this is? Based on what we think this is, we will work our way through the OSI model, starting either at layer 1 or higher. Does that make sense? So yeah, so the computer doesn't turn on. Sounds to me like layer 1, right? That hardware. So I will check cables, stuff like that, right? Or the computer's on and everything's working, but you know, we got no network on this computer, right? I might start at layer 1, which is what about the cables? You know what I mean? Before I will go and start looking at things like the email server, that type of thing. You get the idea? So layer one's often a good place to start. So that's what this is talking about. When you have a problem, gather some information, establish a theory. What do I think is going on here? Based on that theory, start doing some investigation on that. And usually you're going to then work your way through the OSI model. Here's a summary. So we did get to the end. Peer-to-peer is different than client service. Did I record this? Yes, I am recording because it says there pause recording. So that's good. Peer-to-peer networks are cheap, easy to configure, but they are not efficient when you have many devices on them. As opposed to our client server, which is scalable. So the thing about your client server network is you can scale that up basically as far as you want to go with your network building. And a lot of that's to do with the efficiency because you have direct addressing using your servers. We had switch and a router. Switch works on layer 2 and a router works on layer 3. So we might even not even say switch on router. We might just say a layer 2 device or a layer 3 device, right? And then you would know. But so what is a layer 3 switch? Okay, so that's a switch which will work with IP addresses. And so with modern sort of networks, we sort of we sort of make it a bit fuzzy on those boundaries. And so there's some more application layer, presentation layer, session layer. You guys should be familiar with all of those layers now. And what about emergencies? Be safe. Okay, so halas.